Okay, in JHS, you people did numerals, numbers, where, for instance, um, this number, for instance, let me write 500. Okay, 500. No, let me rather do it 534. Okay, this is the unit. This is the tenth. And this is the hundredth. That's why we say 500 and 100. Look at this. I could split this up to 5 times 100 plus 3 times 10 plus 4 times 1, which is 4. Okay, so the 100th, this occupying the 100th position, so 5 times 100 plus 3 times the 10th, then 4 times the units. So this, I could also write this thing as 5 times 10 raised to the power 2 plus 3 times 10 raised to the power 1 plus 4 raised to 4 times 10 raised to the power 0, because 10 raised to the power 0 will give us 1. This is number base. Normally the numbers that you are used to are all written in base 10. That is why we have the digit 0, 1, 2, 3, 4 up to what? 9. That is the numbers you use. This is in what? Base 10. Base 10, and we call it decimal. Decimal. So this is in base 10. Now we want to look at the behavior of numbers in other bases. Okay. So we are going to pick ideas from here. You see how we splitted this number? Yes, we are going to take ideas from there. So the first thing we are going to do is to learn how to convert. So conversion. Okay, so we will learn how to convert other bases to what? Base 10. Other bases to base 10. Okay, so for instance, I'll write a number in base 2. Now one thing you should know is that, you see, this is in base 10, so the last digit here is what? 9. 10 itself is not here. We started from 0. So if I'm writing a number in, let's say, base 2, the last number should be less than 2. So but you always start from 0. So 0, 1. These are the numbers in base 2. So if I move to base 3, 0, 1, 2. So you see that there are 3 numbers over there. Base 3. So 1, 2, 3. In base 3, 3 itself is not there. You get it? So the thing is, once you are writing numbers in a certain base, the base should not be inclusive. The last number should be what? Lesser than what? The base. Okay, that's why in base 10 we end at 9. So every other number is just formed from what? All this. So let's look at this. If you are converting from other bases to our base 10, we are going to use this process. Okay, so let me write a number such as this in base 2. This number is in base 2, 11011. All the digits here are less than 2, and then I've placed the base 2 over there. So this number is what? Less than what? Base 2. Is in what? Base 2. So if you want to write this number in base 10, you are converting this thing to base 10. What you do is, you see here, we said this one is occupying what? The unit, the 10th, the what? 100th. So that is what? From 0 position, this one was at 0 position. You see the exponent. If you move to the next one, this is in the 1 position. That's the exponent 1. Then if you move here, it is what? In the 2 position. That's the exponent of 2. So I'll do the same numbering over here. 0, 1, 2, 3, 4. So counting from where the base is, this one is occupying the 0th position, just as what? The 4 over here. You see, we are using the exponent too. And then this is occupying the 1st, 2nd, 3rd, 4th, counting to your left. So then if you want to convert this become 1 times the base, just as we did here. This is in base 10. That this 2 raised to the power the position 4. Then another, this is 1 times the base 2 raised to the power the position 3. 0 times the base 2 raised to the power the position is occupying is 2. 1 times the base 2 raised to the power its position 1. Then 1 times the base 2 raised to the power its position 0. You see, now this will give us 2 raised to the power 4 is 16. That's 1 times, that will give you 16. And then here 2 raised to the power 3, 1 times 2 raised to the power 3, that will give you 8. 0 times any number is 0. And then 1 times 2 raised to the power 1 is 2, times 1 will give us 2. Then plus 2 raised to the power 0 is what? 1. 2 raised to the power 1 will give you what? 2 times 1 will give you this. 2 raised to the power 0 is what? 1 times 1 will give you 1. And if you add all these things, this 24, 26, and then 27 base 10, you have converted it. If I give you a number, let's say 3, 5, 1 in base, let's say base 7. Okay, so this 0, 1, 2. So then we start 3 times the base raised to the power its position, 5 times the base raised to the power its position, then 1 times the base raised to the power this. Please, you should take note. Okay, let's finish this, then we do our take note. So this is 49. That's 49. And then so we have 49 here. 49 times 3 will give us 147. This is 7 raised to the power 1 is 7 times 5, that is 35. 7 raised to the power 0 is 1 times 1 will give us 1. If you add all these things, you get 135 plus 147 will give us, that's 35 plus 147 will give us this will give us 8. That will give us 1 plus 1 will give us 1, 8, 3. Base 10, you have done that. You see, converting from other bases to base 10 is not that difficult. And then if I've given you a number in a decimal form, so let's say I'll give you the 2, 3, 1.2, something like this. Then I say convert this. Now if you are numbering this one, you see there is a decimal here, so let's start counting just as we did over here. This will be 0, 1, 2. There's the position. Then when you are here, you start -1, -2. You see, so after the decimal it is negative. For instance, if you are drawing your number line, you see after the decimal here is negative, then the ones here are what? Positive. So 0, 1, 2, just as we did up there. So this will, let's say this thing is in base 4, so this will be 2 times 4 raised to the power 2 plus 3 times 4 raised to the power 1 plus 1 times 4 raised to the power 0 plus then 2 times 4 raised to the power -1 plus 2 times 4 raised to the power -2. And then what? You perform this arithmetic and then you get your answer. You will get it in a decimal. I think this will give us 1632. This will give us 4 times this will give us 12. This will give us what? 1. This will give us 4 raised to the power 1 is 1/4 times this will give us 1 That's 2 over what? 4. 4 raised to the power this will give us 16, but that's negative, so that will be 1 over 16. So 2 over what? 16. If you add all these things, you will get 45 plus this will give us 0.5, and then this will give us 0.125. So if you add all these things, you get 45 point. You use your calculator to add it, you get that will be 625 base 10. You have done it. But take note. For instance, I'll take this. 2 times 4 raised to the power 2 is not the same as 2 times 4 all raised to the power 2. So don't write this. It is this. It is only the base that is having the exponent, not the whole thing. Okay.